deep for 48 hours.
Okay. All right, welcome to our weather discussion. Today we've got a lot to talk about, so some of it will be abbreviated because I think we want to focus on the upcoming event, which is really, I think, going to be an historic event in the state. Whether that's exactly met here in Dane County, I don't know, but there's been a bit of waffling even since late last night on that. And we're back into maybe the thick of it. But certainly places to our north are going to experience a once-in-a-lifetime sort of event, I think. That's safe to say. And it's got a lot of cool ingredients. And I would say this, that broadly speaking, we're in a period right now in the Western Hemisphere anyway, of the Northern Hemisphere, where it's been extremely stormy. And I think last night was a remarkable event. Still not over for us. It's still pretty windy, but gusts over 60 miles per hour are no longer, uncommon. We had them all night long. We had sustained winds in the 30s, and tree damage in my backyard. We had a giant thing come down. I just had tree work done on another tree, so I heard this thing happen at night, and I thought, man, they didn't get that. They looked really, I stayed home to watch them, and they were really comprehensive. It was another tree. So, and I didn't even suspect this one had any trouble, but it was huge. I looked out the backyard, and I couldn't believe it. Just unbelievable. So I got to work on that when I get home. But here we're looking at the West Coast satellite movie for the last week, and it's worth to see all of this stuff. So number one, here's the state of Hawaii. And well forecasted this week was the development of this cutoff, which became stationary to the northwest of the state, really sat there. So you can have your attention drawn to that. There's a cutoff over central Baja coast, which kind of drifted into the southern plains of the United States by the end of the week. And then, watch at the beginning again, you'll see considerable cold air outflow off of the high latitudes of Alaska, over land and also over the Arctic Sea. Here it is. And open cellular convection. Occasionally, these clumps of convection kind of organize into some sort of mesoscale circulation. Here's the cutoff that's developing and remains stationary. Watch one of these things. I was wondering with Pete, look at that one. It develops into this beautiful comma, but then it gets sheared away, I think probably because the flow here, cold air here and much warmer to the south. You can see it in the clouds, even in the low-lying clouds. There's an extraordinary baroclinic zone at about, 45 degrees, or I think 45 degrees north. And yeah, look at how widespread the cold is and much warmer here in the ridge. And so there's a lot of stretching along this line. And so when this thing emerges, perhaps organized by the high terrain of the Kenai Peninsula, it just can't survive the stretch. And I don't know if that's it or not, but it'd be worthy of investigation. So unlike many of the other disturbances that developed in the cold air in the Gulf of Alaska this last week and made landfall along the British Columbia coast with probably not major effects, but certainly notable impacts in certain locations. That didn't happen. And this cutoff was a really nice example of a breaking ridge, and then a southern feature of that ridge breaking, of that wave breaking, was the development of that cutoff. So it's really interesting in the Pacific. What's also interesting is very little activity on the ITCZ, all the way to the date line. It was all in the mid-latitudes, but a huge cold air mass flooding the northeastern Pacific basin, and that sets up conditions for what we're looking at this weekend. And we'll try and say that when we look at the obs in just a minute. So that's kind of an interesting evolution. I'm really captivated by that one. And then its quick demise just off the Queen Charlotte Islands. Can we go to the week-long North American map, where we'll look at North America and adjacent waters? So look at the scale of that ridge that you can intuit by the clouds. So this is the whole week for us. We had some moments of really heavy convective showers last weekend that kind of went on and off. At least that's what it seemed like when I was waking up or falling back asleep, I suppose. But it seemed like they were just 5 or 10 minutes long sometimes. Here's the cutoff coming into West Texas, and it fueled the next round of convection, which we actually got a little bit piece of that as well later in the week. So that was like a tropical air mass that kind of made its way across the northern states of Mexico and got ingested into the next part of the flow. So for the first time in a long time, we've been in the vicinity of southwesterly flows, and the temperature's risen, and the likelihood of interesting weather has gone up at the same time. But then when this ridge crashed in the Pacific, the flow got to be really zonal at high latitudes across the country, and then it's one storm after another. Last night was the first one. Kind of emerged as look at that beautiful comma shape that emerges right over our state. And so you're pumping mass out of the column all night long there, and right over us, pressure is getting lower, huge pressure gradient force, extraordinary winds are the result. And so probably the windiest night that we've had in, I don't know, several years, at least for me. I can't think of a windier night that's not related to and only limited to 5 minutes in the vicinity of a thunderstorm. This was howling all night long. I felt like it was in the upper Hebrides in Scotland or something. It was just awesome. So, but that's not the end. So we had convection at the beginning of the week, then we had this beautiful, intense development right over us, which we'll investigate with some of the upper level charts. And then the next thing coming is, of course, not even put together yet. But some of the elements will be evident in the upper level charts right now. So we'll take a look at that in just a second. I just want to see this one last depiction of this evolution as it comes down out of Canada. And so we want to see how does that actually develop like that. And then here comes the next disturbance. It doesn't even look like anything right now. So that's the challenge today, is to try and make sense of it. And it's been the challenge for the guidance as well, because whatever the ingredients are, they're emerging out of the Northeast Pacific onto the land where there's 4 soundings. You know, Canada hasn't cut back on like we have. But there's 4 soundings over this huge geographic area. So every time there's a new piece of information, the forecast changes a little bit in some of the guidance. So it's you know, data-dependent initialization there. So Pete, let's go to the next rad, take a look at what's going on across the country in terms of that. And so here's the composite. I think it's just the last 3 hours. So you can see the tail end of the event that got us last night. And in all the characteristics that visited us are evident still, even though it's well to our east. That is, the leading eastern side was the precipitating side. So we had some snow and rain a little bit last night between 6 and 11 p.m. Then the center of the circulation is now over central Michigan, but it was over us overnight, and we really could hear it. And then there's absolutely nothing falling out of the sky to speak of back here now, and I think we're getting breaks in the, it's almost completely sunny, but breaks in the clouds here and there. And we could take a look at that. We won't, but there's beautiful satellite imagery that you can look at to see the sort of low-level stratocumulus clouds and breaks between them that are evident in the strong flow across the state. And then here's the precipitation stretched across the long axis of Montana, then the southwestern part of South Dakota, and then look at the steady precipitation that results from the Cascades when there's straight zonal flow hitting the high terrain. Pretty intense there. But this is probably relatively light. So it doesn't really suggest, oh, well, we got something to worry about here in the next 2 days. That's the beauty of this kind of thing. You know, if you're a physicist over one of these cyclotron labs or something like that, you got to look at an experiment that runs a month and you're hoping to find one little thing. Here we have 2 days to wait for this blob to turn into an epic storm, which is thrilling. So we win. Okay. I can hear my daughter laughing if she heard this in it. Okay, let's take a look, Pete, at the surface obs first, just to put into context what we've been experiencing. So I'll get the big map. And I'll just draw your attention to some of the winds and the weather around you. So look at these sustained winds now in the state of Michigan, closer to the center of the circulation, which I suspect is probably in the upper peninsula region, or almost in the upper peninsula. But we're in 992, 991, 987.6 is about the lowest reported pressure. And that's up there on the eastern shore of northern Lake Michigan, so with light winds. So that's near the center. And so light snow in the northern part of the state, some moderate snow over in the upper peninsula, and light snow, moderate snow here at is that Marquette? I forget which one that is. Heavy snow at Superior, which is choice. 27 over 24, heavy snow. But the winds broadly are in the 20-knot range, and these are sustained winds. These are not gusts. Yeah, so very strong winds.
John,
yeah.
Could Pete bring up the METAR from just the last hour or so? It's 1642 METAR. You can see that last right there. Look at the winds there. Oops, you said it. 30 out of 300. 56
56.
Knots.
Yeah, those are the gusts. Yeah, that's impressive. And there were gusts, you said, over 60 at some times earlier today, right?
56 knots. That's about 64.5 or so miles per hour.
Oh, miles per hour. Okay. Yeah, so that's impressive. And between buildings, you know, wandering around working here, between these tall buildings, it's been thrilling. We saw several leaf devils because it didn't rain all night, so they were all over the place. Pretty neat. And then Pete mentioned and showed from one of the Lake Mendota cams that the lake's completely opened up by virtue of the wind breaking up the ice that was left. And that's, I saw that firsthand once, I think it was in April of 2000, and these big sheets of ice get dragged up on shore, and it's kind of a well-known phenomenon, but there's a little stone jetty that comes out at Governor Nelson Park up on the Middleton shoreline of the lake, and we saw a giant football field-sized piece of this ice coming integral, coming at the jetty, and it was coming at about 1 mile per hour. We waited a whole hour. My kids were 8 and 5 at the time, and it just crawled up the jetty, and we were racing down this way, but the sound was just otherworldly. Never seen or heard anything like it again. We could do it today, but it might not be the right thing. But the winds are out of the winds are out of the north west in this case, or I guess west northwest. So it wouldn't be perfect like it was that day. They were southerly winds that day. Okay, I just wanted to give a flavor of the strong winds. Now let's go to the upper level charts, Pete. Let's start at 500 millibars. So here's the 12Z 500 millibar map. Oh, what a remarkable map. Look at this thing. So first of all, here's the trough associated with the development that's now, as we saw, right over northern Michigan. That's where the center of the cyclone is. It couldn't be a more perfect relationship between what one expects from the upper chart and where the development is most intense. So it's perfect. Downstream and in the region of, just downstream of the region of strong curvature. And there's even a little bit of a ridge downstream, so the agiostrophy is pretty intense right over northern Michigan. But what I'm also drawn to is this extraordinary baroclinicity. And this is related to what we saw in the Pacific satellite picture, the flood of cold air off of continental Alaska and across the Bering Sea, which for a while was almost perfectly zonally oriented, which would be this line right here. So don't be misled to think that it's going to be straight across the map. This hardly deviates from zonal orientation until we get near us. But that's a huge, several thousand kilometer long transect to that, and it continues even further out. So, and the temperature on the cold side is minus 35, and then colder to the north. So this is a widespread region of temperatures at 500 millibars, well below minus 40. There's a pocket here over the archipelago that's below minus 45. So this is cold for mid-March. And then it's as warm as minus 20 in northeastern Washington, and then the minus 20 isotherm comes just into central, maybe southern Illinois, northern Illinois, sorry. So extraordinary 500 millibar baroclinicity, and right from about the Dakotas into our region, there's cold air advection in really strong cyclonic shear. Look at this wind here at Lincoln, Illinois. 125 knots at 500 millibars. It's only 60 at Minneapolis. It's 65 in southern Michigan. It's 20 at Marquette. So we've got, or near Marquette. So we've got extraordinary cyclonic shear and cold advection, and that just means that the tropopause is being pushed downward over the state of Iowa. And that portends for this particular development is not going to cease very soon. It's going to be a pretty intense continued development. We'll see if that's not borne out in the forecast. Broad ridge over the northern part of the Atlantic, but punctuated by a trough over the Maritimes. Andrea, I was telling Michael, this strikes me as a very stormy March this last 10 days or so. I mean, it's exactly the kind of thing where one of the species that we're hoping to look at. So how is something going to emerge out of this, which was the blobular sort of region over southwestern Canada and the northwestern United States? There's a couple of clues in my mind, and I know I sound like a broken record, but I think there's some clues here. First, by this analysis, it's really difficult to determine what the geostrophic temperature advection is in that region. It's close to zero, but when it's not zero, it's just slightly negative. And so I think there's probably forcing for descent along the axis of the jet, and that is going to be tropopause fold inducing. And that's a good ingredient to have in your back pocket if you want to see some substantial development downstream in time and in space. So that's one thing. And it's very, very, this is just luck of the draw, taking the obs at 12Z. It's very stealthy at this time. And had I not had class beforehand, I would have probably been in Viz 5D and looking for some subtle clues about that. But we can do that in some of the other guidance. It won't be quite as dramatic. So that's one thing I think that's going on. The other is the proximity of very cold air. It's not really warm to our north. There's it's not mid-March warmth. It's unusually cold. And the third piece is, this is just a very energetic flow. So let's go to 300 millibars, Pete. Go ahead.
Let me just also add something.
Yeah.
I believe that trough that's just off the west coast is also a key player.
Oh, yeah, I bet it is. Yeah, okay. I was not aware of that, except to see that it's there, and it is characterized by geostrophic cold convection. So it's going to intensify. So it might be that it's this feature along this baroclinic zone that really rolls along. So can we go to 300 millibars? And at 300, we're looking at a 160 knot jet roaring across the northern plains of the United States and the southern parts of the prairie provinces. It's got a little bit of an anticyclonic tendency to it. And then here's the end of the jet entrance region, and that's where the upper level trough is. So we're going to have at 500 millibars. So there'll be ascent here and descent here. And so that's not particularly cyclogenetic, but it might also be fairly weak. But here we are right at the jet exit region, which is not too stubby except over Wisconsin. That's where the development is. So there's some nice relationships that are evident here as well. And then 186 knot jet roaring south of the southern tip of Greenland and across Labrador. Look at that, 160 knots. We would have just put a balloon up and not even flying a plane to get that one. That would have been nice. But no superposition, which plagued us the whole project, because that far north, you just don't see the subtropical jet make excursions like that very often. Let's take a look at 200 millibars just to see if there's any separation between two jet structures. Maybe there's a little hint of a subtropical jet over southern Florida and parts of the western Bahamas, but really this is the upper level portion of the polar jet. The wind speeds are 40 meters per second lower, and this is 156, so it's also sort of the upper portion of a polar jet. There's not much subtropical jet activity in this portion of the Western Hemisphere today. So that's interesting. Maybe just a little bit here across Mexico and then Florida, but it's not very strong. Okay, can we go to, what's the one I can draw cross sections? Tropical? I think tropical. Let's go to tropical and take a look at this upper feature in the west. And not so much the trough, but the flow out ahead of it. So we might have to go to North Pacific or something, I'm not sure. Regions is down lower here. So let's try North Pacific. Yeah, let's see if we can get a cross section here. So we'll try and get one. This was the baroclinic zone. Now we're looking at 1,500 thickness, which is a proxy, but we were hoping to maybe cut a cross section along about right here through Washington State. And then I think that's, I don't know what that one is.
Control and then button.
So maybe along a line like this. Yeah, great, thanks, Pete. And let's do a PV first. See what the potential vorticity looks like. Sort of maybe midway, maybe a little bit biased toward the upstream side of the jet. So here's the jet core at 120 knots right there at 300 millibars. And the green lines are potential temperature isentropes. So that's a pretty strong upper front. It comes all the way down to 650 millibars. So does the 2 PVU isotel. So that's a pretty decent looking upper front right at this point in the flow, and we're kind of looking perpendicular to it. So this is one of the upstream pieces of the puzzle, but even further upstream is this trough. So it's going to be interesting to see how these interact. But look at how there's strong horizontal shear and then strong vertical shear in the front. Here there's no frontal contrast in theta, but there's a horizontal shear. Here there's both horizontal and vertical shear, and that's the frontal structure. Really nice. So that's what I have my eye on upstream to see what's going to be going on there. And I think that's all I have to say, because Michael's got a lot to say about what might happen next. So I'd like to...
I have a lot of questions. I don't have...
Oh, a lot of questions. Grant.
Is there any impact from the terrain on the development of this upper front?
Impact of the terrain. My guess, my instinct is no. Not substantial anyway, because much of what goes on to start forming this fold in the tropopause, the descent of this air, is occurring at the original tropopause, which may be more or less unperturbed by the terrain. On the other hand, the coastal range here in British Columbia and certainly the northern Cascades have peaks that are 14,000 feet, so that's roughly 600 millibars, or maybe even lower than that. So they don't have, and you can see here, this is probably some of the lower peaks of the Cascades going up to 800 millibars. They're actually deeper than that. But I think since the processes that originate the fold are probably at the level of the tropopause to begin with, they don't probably have too much impact from the underlying terrain. Perhaps waves that emanate from the terrain have some role to play in local modification. I'm not an expert in that, so I wouldn't be able to say. So my guess is probably not, but I'm not certain of that. Any other questions or comments? Okay, all right, thanks, Pete, for driving around. And now Michael will tell us a little bit about what's coming next. Not much to talk about.
Not much to
You want this?
Yeah, thanks. Yeah. We're gonna go, as we always do, to Ty. And we're not gonna look at too many of the maps from our wharf simulations. There's something screwed up, I think, with the Genpec driver. But we'll go to the meteorogram first, and obviously the cold weather that we have. We're stuck in it today, tomorrow, kind of chilly, and Sunday we warm up nicely, maybe getting into the, this may be a bit warm, but we could be, low 40s, maybe close to 50 degrees. And then we have some precipitation as well that's expected, and as we'll see, it's gonna be cold enough for at least the first part of this to maybe be a bit of light snow. But the real event is beyond this map time, again, one that I think people are interested in talking about. So tomorrow probably a dry day, but probably cloudy, and then maybe the possibility of some light snow, then changing to snow and rain tomorrow evening into Sunday. But let's now go to the time height section, please. Now we can see here, okay, really the deep tropopause, as that upper trough moves by, really strong northwesterly winds becoming more northerly, then light out of the east and then southeast over the course of the weekend, and then a very brisk east-southeasterly flow that becomes more southerly, and that's when we begin to warm up. You'll also note in the isotropes here in yellow, as they sort of begin to lower, indicating that we're having significant warm advection and the warm air is arriving here, but they're so closely packed together, this is sort of a frontal zone that we're seeing as in the time height section. And so we're going to have a warm front that'll be just to the south of us or maybe just over us by the end of the period. North of that front, we're going to see, I'm looking at this in time, but it's also in space, you can see the strong ascent that's forecast, the column becoming relatively, very high relative humidities in the column with that ascent. There's our precipitation beginning to develop. And when we look at a surface map around this time in the forecast, we'll see that that's largely driven by surface frontogenesis that's just right over us. But again, this isn't really the big event. Let's go next, Pete, to the zoomed in maps. We'll run this loop first. This is just the first 60 hours, then we're going to switch over, look at the GFS, look at the icon model, and then eventually look at, if we have the early pieces of East and WF, maybe we'll get a chance to look at that. So we can stop that, Pete. And we can go to tomorrow morning, 24 hours. Let's go to 24 hours in the forecast. Go back a couple clicks. So we were tomorrow morning, temperatures in the mid-20s, and it's relatively dry here. That precipitation that we saw on the radar and as well on the radar that extended from the Pacific Northwest into the northern plains, we're going to begin to get into that area of precipitation, which is going to be well to our southwest at that point. And that's advancing ahead slowly with this. There's the departing cyclones well off the map at this point. But most of the day tomorrow, just dry, lots of clouds as the column over us begins to get much more water vapor into it, and relative humidities are increasing. But this looks like, for the balance of tomorrow, dry. Let's go, click ahead, 30 hours, 33 hours. There, we begin to see a little bit of light precipitation, probably in the form of snow. We could look at some vertical profiles, some soundings from model soundings. But really, this is suggesting a band of precipitation that begins to set up just to our north, lots of airclinicity to our south. So this is really, we're still in the cold airs over us, but you can see warm temperatures all the way up to close to 61 degrees in the southeast part of this map and southwestern part of the map over southwestern Iowa. So warm air is not too far behind. Let's continue advancing this from tomorrow night. Precipitation begins to intensify, but largely to our north. Surface temperatures here are well below freezing. You can even see at the surface, we'll look at some other levels, that there is some modest confluence of the flow here along this band of baroclinicity. which isn't strong, which isn't particularly strong, but we have barometric air confluence. This is largely frontage and apical precipitation forced maybe more strongly when we look at some cross sections much further toward the north. But here's where the main precipitation begins to set up. By the way, these are 3 hourly amounts, so we're already looking when we get to the yellow. Scroll up, lift this up just a little bit, Pete, if it's still, oh, there it is right there. So that's like 0.38 to 0.5. So we're getting some fairly significant amounts of precipitation, largely in the form of snow in the north, the sort of central part of our state at this time. We're sort of in the southern edge of this, just below freezing. At this time, this is at 1 o'clock in the morning on Sunday. Let's keep stepping ahead, please. Now we can see the sort of nose of really warm air that begins to move northward through central Iowa. Again, snow is locked into our north from Green Bay all the way to Minneapolis. There's the snow, and we're still just with some light precipitation, just maybe a bit above freezing during this time period. Let's continue going forward. Again, really strong. I mean, characterize this as somewhat, not quite a jet, but a low-level surge of warmth with this thermal ridge that's being created. And you can see the precipitation that really springs out ahead of it. And by this time, most of the precipitation is just to our north by Sunday morning. Let's go ahead a few more clicks. And then get precip, but at this point, it's largely in the form of rain. If this model forecast is correct, we're going to be just in the upper 40s at this point with lots of rain. But just a few counties to our north, still probably freezing rain and snow, maybe ice pellets at that point. The nice cyclonic circulation shows up in this particular forecast. We'll look at a couple other ones just through central Iowa, just to the, I guess, to the east or east-northeast of Des Moines at that point. And so you might think this is all over, but again, this still really isn't the event. Now, I'll have to say, this time yesterday, I was out of my mind in terms of enthusiasm for, a blockbuster, a monster snowstorm. I mean, their model amounts were going anywhere from, they're up to, the high 20s in terms of inches of snowfall. And that seemed like that could possibly sort of pan out. But more realistically, some of the other models had much lower amounts, only just a few inches over us. But I also recognize that the real event starts after this time period, probably after dark on Sunday. This is 60 hours in the forecast. It's 54. We can go one more time step ahead just to get us there. And you can see actually a couple things happen in this. As the cyclonic circulation begins to tighten a little bit and the barochronicity begins to tighten with this stronger frontogenesis, we can see the cold air begins to get dragged down to the north. This is around the time in which I think the cold air is going to be coming in. A couple things are happening. We'll see this in some of the other forecast maps. A deepening cyclone is going to have associated with those, obviously, these steepening pressure falls. Those pressure falls are going to help accelerate the aegis-driven part of the wind down toward the maximum of the pressure falls. You also have strong frontogenesis occurring. That's going to also slow the progression of this warm air northward. So you're going to probably have a tendency with the aegis-trophic flow to begin to eject colder air southward. So sometime late Sunday afternoon, early evening is when we're going to begin to see things beginning to get more interesting closer to us, with some of the precipitation that had been largely focused well to our north begin to get closer to where the surface cyclone is and where this barochronicity is. But again, the big event is going to be really after this time period. So let's switch from this map, please, Pete, to, let's go to pivotal, and we'll go to a similar time. We'll go to 60 hours, just to see how well these match up in time and location. I think this has a surface cyclone that's at 60 hours. That's right.
Do you want me to zoom in?
Yeah, we can zoom in. That'd be good. Now, yesterday afternoon I said really enthusiastic. This morning when I woke up and I came into work, I was talking to John about this, and I was kind of like, let's just get over with this. This is not gonna happen. This is not gonna be exciting. In fact, let's just go and compare this map time. It may not be too different from the 60 run. Yeah, you might say it doesn't look too different, but it's really going to be what happens afterwards. So we'll go back to the current run. Please, Pete. Okay, here are in Dane County with ice pellets forecast over us and sort of moderate to heavy snow, this band further to the north. But we'll just watch the progression of the cyclone as we move forward a couple clicks. This is largely still frontogenically forced, and we'll do the tropical tidbits into a cross section in just a second.
Ooh, that's
You look at this cyclone, it hasn't really deepened too much. We're now going over to snow. This is at 10 o'clock at night. Snow begins, and you might say, well, it looks like the back edges here were all over, but still, the event hasn't really gotten started, I think, really cranked up. In the GFS, that may be the case, but in some other simulations we'll look at, I think it's, things begin to linger a little bit. So let's actually go to tropical tidbits, and we either go to 60 or 63 hours. We're going to do a cross-section through this baroclinic zone that's just over us. Let's go to the Cronus. Let's go to 60 hours. I know I looked at that earlier. It's a pretty good time. And let's draw a cross-section, maybe from Minneapolis down to northern Illinois. And up there it goes through us. So we're kind of in the middle. And we'll look at frontogenesis yet. And you can see this really nice, intense frontogenesis, right? Isotropes being packed together by the larger scale flow. And that's going to be associated with significant ascent. We have it near the surface front as well, but it also slopes upward in general within this cross section. We're seeing a significant ascent. And that's associated with the precipitation that we're seeing here. If we click on this and just look at the water vapor, relative humidity in this case, and omega, we have to do submit, yeah. Okay. And there's our ascent. It's fairly moist. There's not much strong descent over us at this point. And you can see the isotropes right here, really strongly sloped. That's a pretty nice front at this point. And you can see the southerly flow approaching this front, but also the northerly flow that's, has a significant angle across the isobars indicating significant agiostrophy at low levels. That's going to give us that's associated with that frontogenetical circulation.
that air that's coming in, from point B on the cross section, looks like it's in a region where it's convectively unstable.
Right.
But how much do you have to lift it to make it realize that is a good question.
Right. So that's going to be an interesting factor in terms of will some of the precipitation that we have, particularly later on Sunday evening, Sunday night, could it be sort of punctuated by some deeper bursts, maybe with even thunder and lightning?
Oh man, this is really fun.
Okay, let's go ahead one click at least to, I can't recall what their time interval is on their maps. Six, all right, so it's 6 hours. Okay, we get this period where where things apparently begin to dry out. This is something that was noted by some of the folks at the forecast office in Sullivan. But a lot of moisture aloft, a lot near the surface. So have to see what happens with that. But again, it looks like we're still getting, during the time period, the last 6 hours of this run, still significant precipitation falling over us. Let's get out of this and go back to the maps and just look at this a little bit more carefully. And actually, let's go back to pivotal.
Yeah, I don't know where that dry air would come from. I don't understand.
Yeah, that's just an odd thing. So let's go ahead one more click to 66 hours. Again, precip amounts stop for a little bit, but then we have an increasing area of precipitation here. Let's go to a larger map because I think we have to really look at the large scale. I think one of the factors that's controlling the evolution of this weather system and the snowfall is how the models handle, you can see it sort of in the thermal trough here, the thickness, but it's just what's happening aloft as the cyclone begins to move sort of a beam of us at our latitude and on. There still is a lingering trough to the southwest of it, as well as this upper feature that begins to move around. So let's go to 5 millibars vorticity.
Yeah, that's a PVA feature, isn't it? Oh,
Yeah.
Knows what I want.
That's my thinking. Oh, the vorticity's kind of really strung out. Wait, 500 millibars vorticity, please. So, we have this strip of vorticity, but we also have this sort of nice blob that's just to our southwest. And it's in this region, just downstream of it, where we're beginning to see some of the precipitation amounts begin to pile up just south well south of us, but over northern Illinois. If we go ahead another click to, this would be, what, 4 a.m.? This is upper trough approaches us. Comes sort of just a beam of us, but in this region is where I would expect to see still some significant ascent occurring and precipitation. And we'll see that's going to be verified when we look at a surface map at that time. Let's go to the surface map for one click, please. Here's where in that last 3 hours, this is where broadly the snowfall has been occurring. Again, we have this trough that's lingering back here. The axis of the 500 millibar trough was just, I guess, in northern Illinois at this point. And the cyclone hasn't really progressed much, so I don't know if we're going to say that this is the cyclone, same cyclone we've been tracking, but it sort of stalls a while as this upper feature begins to catch up to it, and that prolongs the snow. Now, one of the things that was pretty true from all the forecasts yesterday when things looked really good was that, you know, the period from 7 a.m. on Monday through probably 1 o'clock in the afternoon, and we're still expecting probably anywhere from 3 to 5 inches of snow, no matter what we had on the ground before this, before 7 a.m. on Monday. So let's go ahead to 72 hours. One more click ahead. Again, intensities begin to weaken in this particular forecast. You know, heavier snow just over, just south of Lake Superior and over the northern part of our state. But windy. You'll notice the winds here, I think, were largely sustained at 25 knots. Let's go to the temperature and wind bars. 25 to 30 knots. You may know where I'm going with this. We're going to have, you know, there's going to be a period of significant snow. It's going to be getting colder. Your temperatures drop to the mid-20s by this time. Strong winds, and depending on the intensity of the snow or how much blowing and drifting that we get of the snow, could result in, you know, some serious conditions for travel. And they may even, you know, the B word might be used in this circumstance, particularly for Illinois, with blizzard-like conditions possible. Let's go ahead back to the surface map. And I want to step to just look at another model before we get into this. So UW-AOS is coming in. Let's not look at it just yet. Oh, what the heck? No, let's not look at it. I don't want to be disappointed. So at least look at the icon. So this run, the icon model has been fairly consistent with its depiction of this band of snow that's really somewhat removed from the surface cyclone. Again, it's in a region that's going to be downstream of vorticity maximum. You can even see here in the thermal trough, there's certainly curvature to the ice, the thickness contours. If we could go to the vorticity at this time, here, Pete, to verify that. Okay. No, here's where the local vort max is back here in the trough, but this is this string of vorticity. This is not the best structure for vorticity. It's going to be downstream of it. But I suppose just on the edge of this, just to our east, to the west of this band right here, there is certainly more TVA by the thermal wind.
Really does too determine the, and what is determinative here is the orientation of the thermal wind to the vortex line.
Right.
It might not be exactly parallel to it. Very often
Right.
it is in such structures like this, but it might not be.
Right. So this is, so this simulation or this forecast output is suggestive of perhaps a bit more snow. Let's go to 78 hours in the vorticity, and then we'll go back to the surface map. Cast the cyclone a little bit further to the east in this, and we'll go back to the surface map. And you can see most of the heavier snowfall is just to the east. If we were to now go to the total accumulated precipitation, snowfall, sorry, the snow at the bottom of the winter section. A little bit Kuchera. The reason I choose this over the 10 to 1 is largely because this looks at the temperature structure in the column from 500 millibars down to the surface and does some adjustment for how much would likely be snow as opposed to doing just a normal 10 to 1 ratio. But one of the interesting things is this swath of snowfall that extends from southwestern Illinois all the way up through Chicago and Milwaukee. And if you go back to some of the model runs, go back 6 hours. Let's just go back in time Pete, on the runs, not on time, sorry, time in the forecast when they were initialized. Let's go back 6 hours, prior run. This didn't really show up. That was sort of I was in a funk this morning, like, God darn it, we're not gonna get something. Go back another 6 hours. Yeah, there was something to the south. A lot of the models had a structure like this yesterday, and then this has now appeared. So the forecasts are still evolving, but I think there's beginning to get some clarity as to when the main event's gonna occur. I think that's definitely gonna be late Sunday night into early Monday. I'm gonna talk about those amounts. Let's actually zoom in first of all, and then we're gonna go through and look at sort of ensemble of some of the outputs from the model guidance that's available at this point. So let's go here, go to the model runs, and go to the GDPS, which is the Canadian model. Has for Madison ending up with a nice total of 17.5. GFS,
12.
a bit more sober, 12.3. Icon, that's us at 7.4, which isn't, even though it looked, no, actually it's a 0-0 run. Let's go back, I'm sorry. Let's make sure we're looking at comparing apples with apples. Let's go back. GPS 17.5, GFS 12.3.
47.2.
It's not. Okay.
53.2 at, oh my God.
So icon is B. That's
You can't get off the 53.2.
yeah, I've lost track. 7.4 the icon, and that's Monday at 18Z. NAM is 6.2, and this RDPS, which I think is another.
Wow, it's a
Canadian
real
model,
mixed bag.
14.2. So a lot of spread. Now let's. All right, we'll go back to forecast map just to see. And as UW-AOS is coming out, and let's go down to their total. At least we have to log in to get to that. So let's first look at the surface map and just look at the depiction of that to see how things are evolving. Okay, and let's go back to 60 hours.
Yeah.
Okay. It's 988. Again, we have a cyclone somewhere in northern Illinois, like many of the model runs had. We're getting ice at this point and freezing rain. And we go ahead 6 hours over to snow, but the really heaviest snow's back here. Here's again this one last burst of snow, or last shot at it in this forecast. So that's when we wake up in the morning on Monday, you're gonna get pretty decent snow, and then at 78 hours, it's finally getting, it's wound down at this point. Its totals, I don't know if you can, I don't think you can log on, but we can look at the 10-to-1 ratio, which is probably not going to be too bad, as we're going to go from wet snow to just a more powdery thing, but not going to be as impressive, I imagine. Still 7.1, that's not good.
So that's the lowest, 7 to 17.
77.
So that's not bad.
Right, and the box and whiskers from the National Blend of Models, do you have that link? Yeah, so fortunately, one of our graduates, Chris Smallcombe at the Reno Forecast Office, shared with us a link. It's out there, it's publicly available. There it is. It's about 1D viewer. So National Blend of Models, what the National Weather Service does is it takes a collection of numerical model outputs, Canadian model, European Center, maybe UK Met, and obviously the NWS models. Let's look at snowfall. And it gives you a way to look at this guidance with these box whisker plots. And so we can go down and look at some of the totals. This is from, if you can scroll down a little bit more, 6 hours, 24 hours snowfall. Okay, so what these are showing are, I believe this is the lowest 10%, this is at 25% of model runs are 3 inches or less. Then this is the median, and then this is the 75th percentile, and this is at the 90th percentile up here. So you can get a range of the precipitation, the skewness of the distribution of snowfall that's expected. Again, this is a 24-hour snowfall centered on Sunday, so we get Sunday into Monday. And so you can see a fairly broad range of amounts, with a sort of median being at about 6 inches or so. So one way to sort of interpret all the ensemble output that's available at the time that this was created. So I think the things that are going to be of interest to watch, because I'm a big believer that you cannot assess for those final snow amounts, even with the guidance that we have at this point, until you really know where that final band sets up, and then just watch its evolution. But I think by Sunday afternoon, late afternoon, early evening, as the heavy snow starts and you watch the area precipitation beginning to blossom over central Illinois and begin to move northward, just seeing how far west the edge of that is going to be a big determinant in whether we're going to get caught into the main band of snow, or it's going to be just to our east like the icon model is suggesting. So I really think it's not that first burst. You may look outside Sunday afternoon and say the ground is pretty much bare, and it's been raining and sleeting and maybe some ice out there, and thinking, well, it's over. But I think it's really wait until Sunday evening and just watch what's happening on that. Yes?
We go back to the weather and look at the ice totals. I think we're missing that part of it.
Yeah, that's a good point. We've been focused on snowfall, but we are expecting some freezing rain. So let's go down to ice. Get out of this. Go to GFS, yeah. Yes. That, and then go to, yeah, so, that's thank you for pointing out, this is gonna be an important factor. Conditions are gonna be, look at that.
What a great
Janesville,
Wow.
0.61 inches of ice. So, power outages as well, in southern Wisconsin. The winds we mentioned are gonna be fairly strong, so there could be down tree limbs and things of that sort. That's gonna be a mess. And then you go over to Michigan and points to the northeast.
You can get that on Canadian model too, if you want to see what.
Yeah, do a comparison. Yeah, GPS. Oh,
Even worse.
that's even worse, yeah.
But roughly the same story, wow.
Yeah, so, and let's look at, I don't know if Icon has that as either or not. That's the German model. Let's go to, focus on its evolution. It doesn't have the ice on there, unfortunately. But yeah, so that's something that I have, honestly, I haven't focused on too much, is the ice impacts. So we may not have necessarily the biggest, snow that we've seen in a while, certainly down in our latitudes. But the fact that we're gonna get a period of freezing rain, significant freezing rain and ice, maybe a quarter inch, maybe even a bit more than that, that's gonna make roads extremely hazardous and treacherous. And then put snow on top of it. So Monday morning could be interesting call for schools and things of that sort,
Yeah.
businesses on what.
I think what we're missing
It's
on
a
the
warm ground.
Canadian models, if you put that snow on top of the ice, that's where some of that snow total.
Okay, so the snow totals are being amplified by the fact that it's both ice and snow combined. That's a good point.
Yeah, so it's just, it's frustrating to try to forecast this.
Yeah.
You don't know what I'm going to be.
So that's excellent point. And, that's something that I guess none of the algorithms here, or at least the outputs that are shown, really distinguish between what's snow, what's ice, what's all liquid. But some of what we saw, some of those high totals could really be freezing rain. The other thing is, the amounts that we saw in the northern part of the state, part of that's due to that initial band that sets up. If you go back to 40 inches or 50 that people were excited about. No, it was a 12-0 run. Yeah, it's on GFS.
You're on snow depth instead of snow total.
Yeah, good snow, yeah. That's another thing, we've had warm days, a lot of stuff is gonna melt pretty quickly, at least in the first bits that we get.
Total snowfall.
Yeah.
That's where it is.
Total snowfall, yeah. Okay, and we can go to GFS.
Yeah, the German.
Us?
59.7.
And I don't think these numbers are gonna be contaminated by any of the freezing rain, but it's really, that's insane. But that's the only model that's really out there that's doing that.
That's falling on top of ice on Green Bay.
Yeah.
So that's gonna be 5 feet of snow on the ice in Northern Green Bay.
How much of that is in the first, let's go back to tomorrow, let's go 36 hours, tomorrow evening.
It's like Sierra Nevada storm.
See, really, they get this all in the last half of that. There's the band that sets up.
Yeah, they're only at 12 by the time you get to mid-morning Sunday or early morning Sunday. That is
Lost a little, yeah. In any case, so again, the picture, at least I'm sort of painting for myself, my mental image of what's gonna happen over the weekend. Tomorrow, just kind of cloudy, maybe a little bit of light snow predicting late afternoon, early evening. And that will continue on and off during the day, you know, through Sunday morning. May even turn over to rain and freezing rain. And then freezing rain, ice pellets, and then eventually just plain rain. But late in the afternoon on Sunday, I think the front begins to creep back to the south as winds turn to the north and the cyclone begins to deepen to our south. That brings the cold air in, and then the real snow event begins sometime after dark on Sunday, ending sometime mid-morning on Monday. And that's where we could get, you know, real accumulations of snow of around 6 inches, if not a little bit more than that. But, you know, I think a range of 6 to 12 is probably not unreasonable. So, John, I don't know if you have a...
I'm wondering if we might set the state 24-hour single snowfall record somewhere up northeast of Green Bay. If this verifies, we could be at the 4-foot range for some places in
Right.
one day, which would be unbelievable. Or 3 feet in one day.
Yeah,
Wow, incredible.
yeah, please.
So I was comparing models through the GFS and the Bureau and looking at their mid-level and unknowable features. And the GFS is a much stronger cyclone than the Bureau does. How would that affect how things play out, especially like how long the residence time of the cyclone is? The GFS is much slower of a solution. The
Well, I think-
GFS is farther south, but it gets the warm air up here anyway. How would that all play in? What would we be looking for to see which one we think is more right, or if it'll be somewhere in between?
Yeah, I don't think honestly, and John, please jump in, and others, you know, this is a good discussion. I don't think the intensity of the cyclone is gonna matter so much. The surface cyclone is gonna matter too much in this particular case. I think the fact that we get a cyclone that begins to deep into our south and southwest Sunday afternoon into Sunday evening is gonna help facilitate the stronger push, if you will, advection of colder air southward. That'll bring that baroclinic zone just to our south, and that's gonna accentuate the potential for freezing rain for a period before the cold air gets deep enough. Obviously, the slowness of the cyclone is gonna help with the persistence, and the position of the cyclone is gonna help with the persistence of the precipitation. It's not gonna be necessarily way too far to the west of the cyclone. I think it'll be relatively close in. I think those are gonna be the factors, but the intensity, it's not certain to me that that's gonna be the deciding factor.
Yeah.
The movement of the cyclone and its initial deepening, I think, are gonna help us get to snow.
I agree. I think that the surface intensity might be an indirect signal of how intense the whole circulation is in the 3D column. And if the GFS has a stronger circulation and that turns out to be right, then the thermal structure evolves in response to that in a way that might encourage more snow here. Because you might get a bit more of an occluded thermal structure that really can place the heavy snow in this PVA band the blob that we're talking about now. It might be a little more focused and intense. If the storm doesn't evolve to that kind of structure, Weather Service is using the word trowel a little bit. You shouldn't use it with respect to surface isotherms. It's not really appropriate. Mid-tropospheric average is better. And if that shows up, then I think we have a chance for a little more. But I agree with Michael's timing. It'll be the Sunday night, Monday timeframe.
And then let's go back to 60 hours. I mean, I want to make this a little bit larger in terms of the, yeah, just the US. Thanks, John. Thanks for the question. Other questions? Yes, please.
Just a question for you, maybe for Dr. Martin too. The record, I think, all-time snow records in Wausau, I think are 25 inches, Green Bay 29. Do you think there's a chance those get broken soon on the system?
Yeah, I think so.
Yeah.
There's a chance. Better than even chance, it seems to me. Yeah,
We could, in fact,
maybe
wanna
especially Wausau.
go to that box whiskers plot for a second and see what the sort of consensus of the models are for that. I think we can put in 2 more characters. KGRB maybe. GRB. Okay, and scroll down.
Oh, that's.
This will be a longer duration, right? You're gonna be adding 2 of these together, at least we can go to 48. But I think you would probably be wanting to put both of these together to get your totals. So for a single day, what was the record for Green Bay?
29 inches.
29.
That's gonna be tough.
You're right, it's gonna be tough, and it depends on how I hate to say it, how you define the day. If it's midnight to midnight, or if it's,
Yeah, if it's any 24-hour period, maybe that's a little different,
Yeah.
yeah, but it probably isn't.
so, may not quite reach that, but for an event, single event, it'll certainly be a big total.
Yeah, it'll be amazing.
Okay. If we go back to the, it's a pivotal for a second. On the this is 850 millibar temperature. And John, the thing that I was sort of focusing on at 60 hours, maybe go ahead to 66, was just sort of this kink that's forming in here as this
Yeah.
lifts northward. If this is the beginning of a trowel-like structure.
Yeah, it's a little bit like that. Does it get any better at 72 hours, even though it's out of our range?
Mhm.
A little bit better. So this is what I meant in response to you too, Tyler. The intensity of the low-level circulation tells you something about whether or not this thermal structure might be encouraged by this development or not. And this one's really struggling to wrap around because of maybe a whole bunch of other circumstances. But even in the most aggressive, this is GFS still, even in the most aggressive model, it doesn't really put together a beautiful, obvious trowel structure. It's really kind of
Let's look
basic.
at this for a second.
It's even less here, right?
Right. I think so. I would say let's go to Eastern WF.
Yeah, it looks more like the GFS in the structure at 850.
Yeah, that's maybe a bit more prominent.
Hmm.
This little ridginess.
But among the kind that, that I get excited about, this one doesn't even come close to one of them.
Okay. And UK Met, I haven't looked at that at all. About the same.
Yeah, so there's something keeping this thing from wrapping up. And I have a feeling it has to do with the stretching downstream of the upper trough axis. It's really
Right.
a long, extensive region of strong stretching that just, there's no way you can wrap that up.
Yeah.
That's it.
But things have changed slowly from yesterday to
Yeah.
today, so let's keep our fingers crossed. Yes. Grant.
How much of this setup do you all think is either favored or hindered by the zonalness of the previous regime? Because like if you get any skewness of isotherms relative to the height contours, you could be setting up some sort of PVA of bad thermal wind, but it's also such a broad, kind of weak region that it might not be contributing much to the development.
I think the system that's passing by us today, that's over Michigan and heading eastward, I mean, sets out the table for this event in that it's not so much looking aloft, but at the surface in terms of the surface baroclinicity. If it were a little bit slower moving and it could advect those isotherms in the cold air further south and then got a deeper layer of cold air over us, I would imagine we'd probably be set up for a much longer, prolonged period of just all snow as opposed to precipitation. But the zonalness of the zonality of the flow upstream to where the upper trough is out of the Pacific, I'd have to give that some thought. I don't really have a sense of it.
Yeah, neither do I. It's a good question. It's a really intriguing question. My feeling is that what's missing here is a perfect distribution of the intense precipitation. I think the heavy precipitation is too close to the cyclone center to really build a ridge downstream, which in turn limits the feedback for the rotation of the thermal field to kind of, insist on a prolonged period of heavy snow on the back northwest side. So if you had heavy snow in southern Ontario, southern Quebec in this map, maybe you'd build a big enough ridge down there that this thing would really struggle to not cut off. And as it is, there's nothing downstream to make it cut off. And maybe the heat's being placed in the wrong spot to enhance that tendency. I think that might be what's going on. One of the things that's contributing. And that's a function of it being so strongly tied to the frontogenesis, which is intense. And, never gets built into a thermal ridge.
Yeah, this doesn't really wrap up as you would expect.
Yeah, no. And to me, it's a mystery, but that seems to be a crucial factor in a lot of these events.
Other comments, questions? John, do you have any numbers in mind in your sense?
I guess I would probably lean to the lower end of that 7 to 17. I have a feeling that, the big mystery for me is what's with this dry air at the mid-levels that we saw in the one cross section, and it's been mentioned in the weather discussions. weather service discussions. I don't really understand where it's coming from.
Yeah.
You can't manufacture it by evaporation. I mean, there's no way that can happen. It has to come from somewhere, and I don't see where it's coming from. In its absence, maybe we get a longer period of time where we have precipitation, and perhaps it's enough to cool things down. Right, exactly right. So maybe we get a little higher than that, than what I'm expecting because of that.
So if we don't have a break in precip, so that, what you're suggesting is sometime Sunday afternoon, if there's no real break in the precipitation, or precipitation rate really.
Yeah, that's a good way to diagnose
That might be a way to, something that says, hey, this isn't gonna work out the same, as we talked about at Weather
Right,
Watch.
that's right.
It may actually end up being colder sooner.
Yeah, and more snow.
And more snow.
Yeah, so that's a really good way to gauge that. If we don't get the break, then that probably means the dry air isn't there, which, exactly as you said, means a little more snow. So maybe 10
Right.
inches.
Right, if we don't get the break.
Yeah.
But the thing is, it doesn't have to be frozen precipitation falling, just precipitation
That's right.
falling.
Any
That's what
kind,
you're saying.
yeah, any kind of point.
Andrea, do you wanna?
I mean, I was thinking the dry air is maybe a remnant of the really long, narrow, sort of folded tropopause that we had earlier, and it's just the remnant dry air that was in that layer as
As
this
it
thing
mixes.
starts to spin up.
Yeah, it's possible.
But I don't know. The fact that
That's
it
what
was
this might
so
be.
linearly aligned with that frontal zone
Mhm.
makes me think that and it was in the mid-troposphere, makes me think
Yeah.
that that's maybe where it's from, but.
And that's a good point.
Well, we will see in the next 48 hours. Thank you. Thank you all.
Thank you, Michael. Thanks,
Thanks
Pete.
for the questions.